In this lesson, we are going to take a look at the assembly modeling exercises. If you just completed the part modeling exercises, you will find the layout of the questions between parts and assemblies to be similar. On the CSWA certification exam, you can expect to model two different assemblies. The first step of each assembly is a multiple choice question, while the second step is a fill-in-the-blank question. The assembly modeling portion of the CSWA certification exam consists of 4 total questions, each worth 30 points, so it is real important you build these assemblies correctly. Now let's take a look at the assembly you see on the screen. This assembly is called the crank and slotted lever assembly, and this is step 1 of 2. This assembly consists of 1 bracket, item number 1, 1 wheel, item number 2, 1 long linkage, item 3, 1 short linkage, item 4, and 1 hook, item number 5, and these parts are labeled on the view. Next in the directions we see units, number of decimal places, and the assembly origin. You will locate all of these part files in your working files folder. Go ahead and open up these part files, and once open, you will build this assembly using basic mates like coincident, tangent, concentric, and distance to name a few. Looking at the first direction here, it says wheel 2 is mated concentric and flush to the end of the middle pin on the bracket, item number 1, and there's no clearance. So if we take a look at the view on the screen, here's the wheel, item number 2, here's the bracket, item number 1. This wheel is mated to this middle pin, concentric and flush. Flush is another word for coincident. So the face of this pin and the face of this wheel are coincident to one another. Now let's go to the second screen for step 1. On the second screen, we see we have a front view, and looking at the directions, we see we have an A dimension of 150. So you will need to apply that A dimension, and based on that 150 dimension, you will be able to specify the X dimension, which is an angular dimension. And you'll see down here, I have the correct angle already highlighted of 74.47 degrees. Step number 2 for this assembly is nothing more than modifying dimension A to a new value of 45 millimeters. And based on that new dimension, what is the new angle X? Let's go to the second screen, and keep in mind on the second step of this first assembly, the question is a fill in the blank. Now let's take a look at the second assembly. This is an assembly of a syringe. It consists of 5 parts, and we have very similar directions like we did with the first assembly. Now there's 2 things different about this assembly. On this assembly, you are specifying the center of mass as compared to a dimension value. And the second item that is different will be more apparent on the next screen of step 1. Notice this dimension A. This dimension A is taken from this face to a face inside of the plunger body. So we're actually dimensioning to features inside of other features. As we build this assembly together, I will show you how to access part features inside of other parts. So let's take a look at these directions. Once again, we have the 5 items: units, decimal place, assembly origin, download the parts, and assemble the parts based on these directions. And we have an A dimension of 61 millimeters. And based on the A value, you will specify the correct center of mass. And this is the correct answer here. And the second step of this assembly is simply modifying the A dimension and specifying a new center of mass. And this will wrap up this overview. Now we are ready to move forward and build the first assembly.